Alright, in this lesson we'll explore the pivot table method, not to be confused with the pivot method which we just introduced. And pivot table operates exactly as it does in Microsoft Excel. It's ideal for taking a data frame or a data set and basically aggregating it to look at the values as a whole. Maybe you want to take the sum based on values in a certain column or the mean, and you want to kind of create groupings or sections based on common values. So if you're familiar with playing around with a pivot table in Excel, it's the exact same concept. The big difference here, of course, is that in Pandas everything has to be written in code. It's a lot less visual, so it may take a little bit more time to get comfortable with this concept, but otherwise it operates the exact same. So let's begin by importing a new CSV that we'll be using just for this lesson, and it's called foods.csv. And it's basically just a list of data for my fictional restaurant. I have the customer's first name, their gender, the city, the frequency of how often they come into my restaurant, which is just a string. We also have the item they purchased and how much they spent right here, which is a floating point column. So I don't really want to spend too much time on optimization here because we're not going to need the CSV for too long. So I'm going to automatically assign it to a foods variable and just preview the first three rows with the head method. Actually, it's going to be foods. And there we have our first three rows. So let's go ahead and directly call the pivot table directly on this data frame. So I'm going to go foods dot pivot table. This is what we want. So let's open this method up and take a look at the parameters. So you can see it's asking us for a values parameter, an index parameter, a columns parameter, and then it has that ag function parameter, which is short for aggregate function, which is how the data is going to be aggregated as a whole. So let's take a look here. For the values, let's say we want to stick basically entirely with the spend column here because it is the only numeric column, and when you're really aggregating, you generally want to aggregate on something numeric most of the time. So we're going to treat our spend column as our values. Now, how are those values going to be grouped or collected? Well, let's say I want to take a look at how much our sales, how many sales came in per gender. I want to group it by gender. So basically what I want to do is get a result where the index is going to be the gender, male or female, and then I want to aggregate the total spend for each gender. So my index is going to be the gender column, and what it's going to do is loop through that column and find all of the unique values, which is going to be male and female. And then it's going to take the values in the spend column and do something with them. And what that operation is basically what we provide in the ag function parameter. So right now it's going to take the average of sales. So if I just leave it here, agfunc equals mean, this is going to give me the average. So when I look at this, I'm getting a brand new series, and you can see the average female spent $50.70 and the average man spent $49.39. Of course, if I switch this agfunc, I have a bunch of different arguments that I can give here. Obviously, one of the most common ones is something like sum. That's going to sum up all the values in spend, grouped essentially by this index of gender. So here we can see that the total amount that females have spent is $25,963, and the total amount that males have spent is $24,106. Again, these values are basically calculated by going through the unique values in the gender column. So it finds male and female as the only two here, so it sets those as the index labels. And then it goes through my values columns, which is spend, and then it basically adds them up based on that index, whether it's male or female, and then delivers the final result. The data is aggregated by a sum. And similarly, if we want to change what column the values are being grouped by, all we have to do is just change this argument to the index parameter. So if instead of looking at it by gender, I want to look at sales as a sum of sales by the item that was sold, we have an item column here. I can just put an item here. And predictably now my index is going to consist of those food items as well as the aggregate of sum of the sales for each one of those food items. Predictably, what we can do is also provide a list to that index parameter, and what it's going to do is create a multi-index for us, something we're hopefully very familiar with by now. So let's say I want to group first by gender, then by item. So I want to see how much each gender bought of each item in terms of aggregate total sales. So what I can do here is provide a list instead of a string, and in that list indicated by square brackets I can just put in something like gender first and then item. And what it's going to do is create a multi-index series, and you can see out here we have female and male, which is the outer layer, and then the items are going to be represented. Basically all of them are going to be represented twice because each one is going to be grouped inside that larger layer of male or female, but you can see them all represented here as well as our total sales. Now let's introduce the next component, which is the columns. So far we've basically been getting these series back, but we can also create additional columns if we want to kind of separate or organize the data in a different way. So let's say we want to look at this similar data. We want to look at the sales by gender and item, but we also want to take a look at it by city, but we don't want to put that city in as the third layer in the column or the row index because it's kind of getting a little bit clustered right now. So now I can take a look. There is that columns parameter, and I can write it out right here. And let's give it an argument of another column that I want to serve as my column values in the resulting data frame. So let's say I want to provide the values in my city column. So now when I execute this, we're going to see that we're going to have a multi-index data frame. We still keep that index of the gender followed by the item, but now it's gone through the values in my city column. It's found 3 unique cities, New York, Philadelphia, and Stanford, and those have now become my columns, and it's similarly performed an aggregation of the sum based on those, based on the values in that column. And predictably, if we want a multi-index column level index, what we can do is simply provide a list argument to this. So for example, if I wanted to do a grouping first by frequency, then by city, I have to close my square brackets here, you can see what it's going to do is once again on the left side it's going to have a multi-index of gender and item, and then it's going to break it down into those daily, monthly, never, often, and so on categories, and then each one is going to be broken down. The second level of that column multi-index is going to be the cities, and then we're going to have the sales here. For example, 231.68 represents the sum of my spend for female customers who bought burgers in the city of Philadelphia on a daily basis. So there you go, pretty comprehensive. So let's now reduce this to something simpler. I'm just going to bring this columns to a single value, which is going to be city, just so that we don't cluster up the whole screen. And here we have a calculation based on sum. And let's just conclude this lesson by exploring some additional aggregation functions that we can do. Feel free to play around with this data set. There's a lot of different ways that you can mold this data and find some common patterns. So we have the sum. We, of course, explored the mean. We also have count, which is basically going to give us how many rows we have that fall into that criteria. So basically this means we had 24 total rows in our data frame that had a gender of female, a value of burger for the item, and occurred in New York. We also have max here. Let's type in max and execute. And what this is basically going to do, again, we're aggregating here by spend, so this is going to give me the max. So what this indicates is for females who bought a burger in New York, the maximum value in the spend column was $98.96. Similarly, for example, if I look at this value, this represents the maximum value in the spend column for males who bought a burrito in Philadelphia, and so on. And predictably, the complementary argument to max is always min. This represents the smallest amount that is present in our original data set. And one other thing that I want to conclude with, basically we've covered everything that we need to do as far as the parameters. There's so many different ways that we can pivot the data that I really can't cover everything, but hopefully this is enough to kind of remind you of how it's done in Excel and just demonstrate to you how the process is basically identical in Pandas. What I'm going to do here is just collapse this and show you that in the previous example, we called the pivot table method directly on our data frame, but it's also available directly on Pandas. So if I do PD instead of foods, I can actually find a pivot table method. And if I open the parentheses, predictably all of the parameters are going to be the exact same with the exception of my first one, which is data. And that's where you provided the argument of a data frame. So for example, if I wanted to replicate this code above, what I can do is just copy everything I have here because all of this is going to be valid. So I'm going to copy it right here. But of course, for my very first parameter here, which we can see as data, I'm just going to write it out. I want to provide the specific data frame that I want to use for that data, and it's going to be foods. So if I execute this, oops, what happened there? I have 2 parentheses at the end instead of 1. There it is. And just to show you here, I'm going to just call the head method here and also call the head method at the end here. You can see that the data frames we're going to get back are going to be exactly the same. So whether you want to call the pivot table method directly on the data frame or call it directly on the PD library and just provide the data frame as the very first argument to that method, either approach is going to yield the exact same result, just 2 different ways to do the same thing. So that's an introduction to the pivot table method in Pandas, which can be used to aggregate the values in a data frame. You can provide the aggregation function, how you want those values to be calculated, as well as what you want to serve as the index and the columns of the data frame or series that will be generated.